Good morning, grade 11. This is Mrs. Pascale. Our lesson for today is the quadratic formula, chapter 4, section 4.7. The objective of this section is to solve a quadratic equation using the discriminant and to determine the number of solutions in each quadratic equation. Solving a quadratic equation. We know that a quadratic equation is defined by ax squared plus bx plus c equal to 0. So to solve it using the discriminant, we need to calculate delta first, which is equal to b squared minus 4ac. When delta is greater than 0, the equation admits two real solutions. x1 in the form of minus b minus radical delta over 2a, x2 minus b plus radical delta over 2a. When delta is equal to 0, the equation admits one real root, x equal minus b over 2a, and when delta is negative, the equation admits no real roots. Let's review how to solve using the discriminant. For example 1, x squared minus 5x minus 7 is equal to 0. We need first to determine the real coefficients a, b, and c. Then calculate delta, which in this case it's equal to 53. And finally, we need to define the roots x1 and x2. So in this example, x1 is equal 5 minus radical 53 over 2, and x2 is equal 5 plus radical 53 over 2. For example 2, when the equation is 3x squared minus 4x plus 3 is equal to 0, define the real coefficients a, b, and c, then delta gives negative 20. So when delta is negative, we know that the equation admits no real roots. Another way to solve a quadratic equation in the form of ax squared plus bx plus c equal to 0 is by using the evident roots. Evident roots are calculated without using the discriminant, and it's mostly used when the calculator is not allowed, especially in the SAT tests. When the real coefficients a plus b plus c gives a value of 0, then we can directly say that the first root is for sure 1, and the second root is in the form of c over a. What do we mean by that? Example, if the required is to solve 3x squared minus 4x plus 2. So before using the discriminant, since a is 3, b is negative 5, and c is 2, and if we add directly the three coefficients, we get 0. So I can deduce directly that x1 is 1 and x2 is equal to 2 over 3. 2 over 3 is determined from c over a. If a minus b plus c is equal to 0, then the evident root is negative 1 and the second root is negative c over a. Example, when the equation x squared plus 3x plus 2 is equal to 0 need to be solved. So we can notice that if we change the sign of the second term of the real coefficient, we can get a 0 value. So 1 minus 3 plus 2 gives 0. So directly x1 is equal negative 1 and x2 is equal negative 2. The second idea we need to discuss in this section is to know the number of solutions of each quadratic equation without even solving it or graphing it. A quadratic equation can have at most two real solutions. What do we mean by at most two real solutions? It can have two real solutions or one real solution or even no real solution. The value of the discriminant determines the number of solutions without solving it. If we study the table, when the discriminant is positive, defined by b squared minus 4ac, the equation by solving by calculation gets two real solutions, and by graphing the quadratic function, we can get two x-intercepts or 2 points of intersection between the curve and the x-axis. When the discriminant is equal to 0, by solving it by calculation, we can get one real solution, we mean one real value of x, and by graphing the curve, we can get 1 point of intersection with the x-axis as shown in the table. When the discriminant is negative, the equation admits no real solution and the curves are either below or above the x-axis. Let's see now how can we determine the number of real solutions without solving the equation. Example 1, if the equation is 2x squared minus 3x plus 7 equal to 0, then by calculating the discriminant delta, we get the value negative 47, so it's smaller than 0, so no real solution, and we can say that the curve does not cut the x-axis. And number 2, x squared minus 6x minus 5 is equal to 0. Delta gives a positive value, so we can deduce that the curve admits two real solutions, or the curve cuts the x-axis at 2 points. In example 3, x squared minus 6x plus 9 is equal to 0. So delta is equal to 0. We can deduce from delta that the curve admits one real solution, the equation admits one real solution, and the curve cuts the x-axis at 1 point.